Today's lecture is about the history of medicine. For thousands of years, people around the world in places like Egypt, Peru, China, and Iraq have treated medical problems with plants. Usually, these early medicines were identified after someone ate a plant and then felt better. People concluded that the plant cured the disease. They used the plants as teas, or they put the wet leaves on their skin. One of the first medicines used worldwide was quinine. It was a tea made from the bark of a tree that grows in South America. People in Peru made quinine from tree bark to treat fevers. In 1632, a Spanish man named Barnabé de Cobo brought the tree from Peru to Spain. Then, from Europe, explorers brought quinine to Asia and Africa. It was used to treat malaria, a common disease in places with hot weather. In fact, quinine was the best medicine available for malaria for hundreds of years. The next big step in modern medicine was identifying the specific chemicals that allow plants to cure illnesses and developing a process to put those chemicals into a pill or liquid. William Upjohn achieved this in 1885 when he invented pills that could be manufactured in large amounts and delivered to sick patients far away. The pills we take today are very similar to the ones that Upjohn developed. Along with medicines, vaccinations have improved world health. A vaccine gives a person a weak form of an illness so that the body is prepared to fight the stronger form. In 1786, Edward Jenner found that he could use cowpox, a harmless illness, to protect patients from smallpox, a deadly disease. This was the first vaccine. In the following centuries, other researchers improved on Jenner's method and developed additional vaccines. Louis Pasteur made a vaccine for rabies in 1864, and Jonas Salk made a vaccine for polio in 1952. Because of vaccinations, most people do not get these dangerous illnesses today. Drug safety has always been an important part of medical development. Today, the governments of most countries have legal requirements for companies that manufacture medicine. In the United States, for example, what is now the Food and Drug Administration was created in 1906 to manage American drug safety. Companies that make drugs must produce them safely and write a clear explanation of how to take each kind of medicine.
Hello everyone. Today, I'm going to talk about something important to everyone here. Actually, it's important to students all over the world. I'm going to tell you about the best way to memorize information based on how the brain works. I'll evaluate 3 strategies for remembering the material you study. I'm sure you all want to hear about these strategies, so let's get started. The first strategy for remembering what you're studying is called visual inspection. Look very closely at what you're trying to memorize. Look at the shape and color. For example, notice the triangle shape of the capital letter A to remember a name like Anderson that begins with A. For some people, it's easier to remember the triangle than the new name. Functional MRIs showed that people who used the visual inspection memory strategy were using a region towards the back of the brain that identifies what the eye encounters. It tells us what we're looking at, and it also stores memories about how objects look. So now we know that you can create new memories about images on purpose. The second successful strategy for quick memorization is called verbal elaboration. Make up a sentence or a word about what you're trying to remember. So, an example of that is the name Roy G. Biv. Roy is not a real person. The letters in the name list the order of colors in a rainbow: red, orange, yellow, green, blue, indigo, violet. For most people, it's a lot easier to remember the name Roy G. Biv than to memorize that long list of colors. It's a smaller volume of information to remember. The functional MRI showed that people using verbal elaboration to memorize objects were using the part of the brain involved with language. It tells us what words mean, and it can remember new words too. The third memorization strategy is very simple. It may seem like an odd thing to do in the middle of the day, but here it is. After you study, but before your test, go to sleep. Research has shown that our brains use sleep to deal with the constant stream of new information we get. Our brains don't have room to store all of that material forever. New memories are located in the hippocampus region of the brain, but they don't stay there for long. They're replaced by even newer memories pretty quickly. To remember something for a long time, the information needs to move from the hippocampus to the neocortex. That's where the brain stores information more permanently. And napping pushes information from the hippocampus to the neocortex. The memories change from short-term to long-term memories while you sleep. I've talked about 3 methods for memorizing information: visual inspection, verbal elaboration, and taking a nap. Functional MRIs have shown that different parts of the brain are involved in each of these strategies. I hope that one of them, or maybe all 3, will help you prepare for your next test.
Since the dawn of man, we have looked up and wondered about the mysteries of outer space. We still know little about it, and we know even less about inner space, the space inside our heads. You are looking at the most sophisticated computational information processing system ever made. It is lightning fast, clever, adaptive, and can often tell if something is wrong with it. In fact, there are as many neurons within this boy's brain as there are stars in the galaxy he is currently viewing. But the universe inside his head, and yours, and mine, is still so vast and so unexplored that we can barely understand how a 3-pound human brain knows how to pick up a glass of water and drink it. The mysterious human brain. We know enough to know we've only just begun to understand the basics. We're not clueless, though. We do know a few things, and those things I like to call brain rules. It's extraordinary what some of our brains can do. Go ahead and multiply the number 8,388,628 times 2 in your head. Can you do that in a few seconds? Probably not. There's a young man who can double that number 24 times in the space of a few seconds. He gets it right every time. There's a boy who can tell you the precise time of day at any moment, even in his sleep. There's a girl who can correctly determine the exact dimensions of an object 20 feet away. Yet none of these kids could be taught to tie their shoes. Indeed, none of them have an IQ greater than 50. Your brain may not be nearly so odd, but it is no less extraordinary. My goal is to introduce to you 12 things we know about how that extraordinary brain works. The brain rules cover such topics as exercise, memory, stress, sleep, vision. The supporting research for each of my brain rules must first be published in a peer-reviewed journal and then successfully replicated. The problem is that so much of what we do in our modern world ignores these brain rules. We try to drive while talking on our cell phones, even though it is literally impossible for our brains to multitask when it comes to paying attention. We have created high-stress office environments, even though a stressed brain is significantly less productive. Our schools are designed so that most real learning has to occur at home. That could be funny if it weren't so harmful. Let's find out why.
devised a whole load of games involving skills like problem solving that exercise the frontal lobes, memory that stretch the temporal lobes, and maths that use the parietal lobes.
You guys generally think that the brain training has improved your brains?
Yes.
Okay, who's keen to find out what the scientific results of this study were? Yes. Me too. Liz?
Okay, it's time for the moment of truth. Now, we already know brain training games make you better at those games, but do they improve your brain power, like some of the commercial games imply? Thank you to all of you in our studio and at home who took part. We could not have done this without you. First up, let's look at the control group that did no brain training at all, but they did spend time on the computer searching the internet. Now, our scoreboard represents roughly the range of scores for all our participants. Let's look at their mental ability at the beginning of the 6 weeks.
This is how they scored on our tests of memory and problem solving.
There it goes. Excellent. So that's the score they got before the 6 weeks. Average score of 4.6. And this is how the control group did after the 6 weeks.
Now, in theory, there shouldn't be much difference.
There we go. Ooh, right. Our test gave them a score of 4.8, so not much of a change there. Remember, that's the result of our control group, so far so good. But now for the interesting bit. Does brain training have any effect on your overall mental abilities? Brain trainers, let's see how you did before brain training, shall we? There it goes. Our tests of memory and problem solving gave you an average score of 4.6, exactly the same as our control group. But how did you score afterwards? Did brain training make any difference? 6 weeks, remember, of brain training, thousands of you across the nation. Did you do any better than our control group? Are you ready to find out? Let's find out. Where's it going to stop? Ooh, that's almost the same as our control group. Can you believe it? Our test gave you, our brain trainers, an average score of 4.9. Are you shocked and horrified? How are you feeling about this? Yeah. Adrian, can I ask you to join me? I am frankly quite surprised by the results. Okay, so we've got 4.8 from our control group, 4.9 from our brain trainers, so it's 0.1 of a difference. Does that mean anything?
Well, unfortunately, when we do the direct comparison between the brain trainers and the controls, the difference is statistically completely meaningless. There is no difference between them.
Okay, but what about the difference between the brain trainers pre and the brain trainers post training? So we've got 4.6 to 4.9. Does that mean anything?
I'm afraid I'm going to have to disappoint you again, Liz. That difference is so small, again, it's statistically not meaningful.
Can we actually say that brain training games don't work?
The result is crystal clear. Brain training is only as good as spending 6 weeks using the internet. There was no meaningful difference between the two groups.
Pretty surprising stuff. I'm sure you agree. Adrian, thank you so much.